All right, welcome back. Let's go on to number 8. Find the length of the segment connecting -3/7 and 5-1. Round to the nearest tenth. Okay, here is the ask. Find the length of the line segment that connects 2 points. Now, when you're finding the length of a line segment, you need to envision that there is a line segment, a starting point and ending point, and you're trying to figure out how long it is. In other words, you're trying to figure out what's the distance from one point to the other. So when you see the word length, what you're really looking at is a distance problem. Now, depending on how you were taught, there are 2 different ways for approaching a distance problem. There is the formula method, and then there is more of the visual method. Let me talk to you first about the formula method. So if you are used to the formula and you like the formula looks like this. Distance equals big square root symbol, x2 minus x1 squared plus y2 minus y1 squared. If you are a formula person, my recommendation to you, write your formula at least 20 times. Any formula that you have to memorize, write it at least 20 times. Alternate colors that you write in. Maybe a pencil, then a colored pencil, then a pen, or a highlighter, or a marker. But alternate the colors, but write it at least 20 times. It's going to help you memorize it. So if you're a formula person, that's the distance formula. The other option is to use a graph and then use the Pythagorean theorem, a squared plus b squared equals c squared, in order to figure out the length or the distance between the 2 points. These are the same thing. This distance formula is used specifically on the coordinate plane, but this a squared plus b squared equals c squared Pythagorean theorem could be used off of the coordinate plane or on the coordinate plane, but they're the same formula. One just uses coordinates right away in the equation, and the other one lets you kind of count and use numbers that are not positive or negative with that formula. I'm going to show you how to use the Pythagorean theorem in order to figure out the length of something. Now, just as a preview, anytime that you have a line segment, your first step to finding the distance between those 2 points, or the length of the line segment, is to draw a right triangle with those 2 points. So you're going to complete the right triangle. Your A and your B value for your Pythagorean theorem are the 2 legs that you just drew in. It doesn't matter which one you call A and which one you call B. Doesn't matter. So those legs are your A and your B. And your C value is the length that you're looking for. This C value is the distance between the 2 points. So our goal is always going to be to solve for that C value by using a squared plus b squared equals c squared. Now let's see what I'm talking about. So let me go to a graph. You guys have some additional graph paper on the back of your review sheets, or grab something and go ahead and graph what I'm going to be doing here. And we're going to take a look at our graph paper and start by plotting our 2 points. So we have -3, 7 and 5, -1. So let's start with -3, 7. -3 up to 7. Okay, make it a little bit bigger of a point. There we go. That's -3, 7. 5, -1. Here we go. And now I'm going to connect it with a line segment. Okay, let's see how this one turns out. Okay, pretty good. So, in order to find the length of that line segment, or the distance between those 2 points, if I'm going to use the Pythagorean theorem, I'm going to go ahead and start by creating my right triangle. So, I'm going to go, starting from the left, I'm going to go down, right, and then to the right. And now you'll notice I have a right triangle here. Once I have the right triangle made, my next step is to figure out what is A and what is B. I'm going to count to figure out A and B. Now, it doesn't matter which one you call A and which one you call B. So I'll call A this side and B this bottom side. Let's just go ahead and count. So I have 1 for the A. 1, 2, 3, 4, 5, 6, 7, 8. So this length here is 8. Do the same thing for B. 1, 2, 3, 4, 5, 6, 7, 8. Okay, again, I have 8. Sometimes the numbers are the same, and you'll learn later in the year that that's called an isosceles right triangle because the two legs have the same length. Okay, now that I have A and B, my third step is to go ahead and use the Pythagorean theorem. A squared plus B squared equals C squared. Okay, so how would we use that? I'm going to go ahead and write it again. A squared plus B squared equals C squared. Remember, A and B are what you just counted. C is what you're going to be solving for. All right, so plugging things in, we have A as 8 squared plus B as 8 squared equals, and now your C squared is unknown. We're going to be solving for it. Notice I never deal with any negatives here. I'm just counting the boxes up, counting the boxes to the right, and I don't care about negative or positive. This isn't like slope. I'm just counting the boxes to figure out the length of those two legs that I just created. All right, let's go ahead and do the math. 8 squared means 8 times 8, and you get 64, plus 8 squared, which is 64. Together, that gives me C squared. Add together 64 plus 64, which is 128. If you don't believe me, let's go to our calculator. 64 plus 64 equals. Okay, so 128 equals C squared. Now, you do not want C squared. You just want C. So you just want to know what is the length of that longest slanted diagonal side. What's C? This is C right here. That's all you want. So in order to get C, you have to get rid of the squared. In order to get rid of something that's squared, you have to do the inverse operation, which is the square root. So square root both sides. Just like the distance formula where you had that big square root, you square root here as well. So let's go ahead and do the square root of 128. In the calculator, I have 128. I click square root, and there I go. I get 11.3137. They said round to the nearest tenth. So 11.3 units is equal to C because the square and the square root cancel each other out. So the length of this line segment is 11.3 units. It's longer than the two legs. The legs are 8 and 8. The length of the diagonal is 11.3. That should always be the case. Your diagonal should be longer than the other two legs. Now, if you use the formula, you would have used the -3, 7, and 5, -1 as your x1, y1, and x2, y2. So you could have called this one x1, y1, x2, y2, plugged into your formula, still have gotten square root of 128, and then put it into your calculator. Both methods are appropriate. I showed you the Pythagorean theorem. Okay, let's move on. On to number 9. What is the distance between r, 10.2, and s, -3.8, round to the nearest tenth? Okay, so they're asking you for the distance between the 2 points. Number 8 asks you to find the length of the line segment. I want you to understand that this is the same exact question. They're asking you to find the length of a line segment or the distance between the 2 points that R and S create. So we can do the same thing for number 9 that says distance as we did for number 8 that said length, either the distance formula or the Pythagorean theorem. I'm going to continue working with the Pythagorean theorem. A squared plus B squared equals C squared. Now remember, your first step is to plot your 2 points and create your line segment so that you can visualize this problem. Let's go to our graph. So we have 10, 2. And then the other point that we have is negative 3, 8. Negative 3 and then up to 8 right here. Okay, so now we're going to connect those 2 points. And do it one more time. I don't like the way that one came out. One more time. Okay, that's better. So this is our line segment that we need to find the length of. All right, first step after you've gone ahead and plotted your 2 points is to create your right triangle. So I'm going to drop a line down and then a line over. And here are 2 sides to the right triangle. So remember, step 1, draw the right triangle. Okay, step 2. The next thing we're going to do is we're going to go ahead and count what A and B is. Got to figure out what A is. We have to figure out what B is. Does not matter which one you call A and B. So I'm going to call the horizontal one A this time, just to show you. Doesn't matter. So let's go ahead and count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 boxes. So 13 is the length of the bottom side here. Now B, that's the vertical line. 1, 2, 3, 4, 5, 6. 6. So we have 13 and we have 6. Step 3, we're going to go ahead and use our Pythagorean theorem. So A squared plus B squared equals C squared. We're going to do 13 squared plus 6 squared equals C squared. 13 squared is 169. 6 squared is 36 equals C squared. Add them together. Grab the calculator. 169 plus 36. Do we really need the calculator? No. But does it make things quicker for right now? Yes. Okay, 205 equals C squared. We don't want C squared. We want C. So in order to get C by itself, we have to get rid of that squared. So we're going to square root the 205. We're going to square root the C squared so that the square and the square root cancel. Now, in our calculator, we need to do the square root of 205. Hit the square root. There it is, 14.31. Now, the question is asking you to find the distance and round to the nearest tenth. So, again, our answer is going to be 14.3. The nearest tenth is 1 decimal place, and that is our C value. So 14.3 units is our final answer for this question, rounded to the nearest tenth. Okay, let's go ahead and go on to number 10. Number 10. Find the perimeter of ABCD with A, B, C, and D as those points listed. Round to the nearest tenth. Okay, find the perimeter. This is our ask. Find the perimeter. Now let's talk. Perimeter means the length of the outline. So for example, if I have this weird looking shape here, I want to add up all of these sides together. This one, this one, this one, this one, this one. When I add them all together, I get the perimeter of the shape. So when you're finding perimeter, all you're going to do is you're going to add the length, or the lengths with an S, of all sides of the shape. So you're going to add together all the sides of the shape, meaning you first have to know, well, what is the length of all sides of the shape? So we're going to have some work to do. Now, our shape is called ABCD. If there are 4 points, that means it's going to have 4 sides. The number of vertices, the number of points, equals the number of sides. Okay, let's go ahead and take a look. I'm going to start plotting. So I'm going to zoom in. And let's go ahead and start plotting. First point, 2, 8. Right there. Next point, 2, 5. Next one, 6, 5. And then lastly, 8, 10. Okay, so those are our points. I'm going to go ahead and label them as well. Don't forget to label A, B, C, and D. I'm going to go ahead and connect all of these points as well. So A to B, B to C, C to D, and then A to D. Okay, here's our shape. It kind of looks like a trapezoid, but not really because the lines are unparallel. So it's just like a weird quadrilateral. All right, now my game plan. I need to get all of the side lengths. So let's take a look at my game plan that I'm going to start formulating over here. So to get the perimeter, I'm going to erase some of this here. I need to add the lengths of all the sides. So how many sides do I have? 4. I have AB, I have BC, I have CD, and I have AD. I need to add them all together in order to get the perimeter. All you have to do is add them together. So we have to go one by one and solve for all of these lengths. So I'm going to have these as placeholders, and I'm going to be adding together all of these values. Let's start with AB. Since AB is vertical, this line is vertical, all I have to do is count the boxes, just like we do when we have to do the right triangle Pythagorean theorem. So I have 1, 2, 3 boxes, so it's 3 for my length. 3. Fill that in. 3. Now I have BC. BC is horizontal. Same thing, it's on the grid lines, so all I have to do is count the boxes. 1, 2, 3, 4. So it's going to be 4. BC is 4. Next, I have CD. Now notice CD is slanted. It is diagonal. I can't just count the boxes. I have to do the Pythagorean theorem or the distance formula. I'm favoring the Pythagorean theorem, so I'm going to go ahead and do the Pythagorean theorem. Go ahead and zoom in. First step when doing the Pythagorean theorem to find length is you have to go ahead and draw your right triangle. So I'm going to go down and over. So this is my little right triangle right here. The next step is I have to count A and B. So I have horizontally 1, 2 boxes, so it's 2. And vertically 1, 2, 3, 4, 5 boxes, so 5. 2 and 5 are my A and my B. I'm going to be solving for this C slanted length. So let me go ahead and go to my spot where I can do some work. And I'm going to put in 2 squared plus 5 squared equals my C squared. 2 squared is 4 plus 5 squared, which is 25, equals C squared. 4 plus 25 is 29. That's your C squared. We just want C, so we square root both sides, which cancels out the square. And now I'm not going to put this into my calculator yet. The reason I'm not going to do that is because I have to add this to some other stuff. If I go ahead and put in my calculator and round early, I may have rounding error at the end. So what I'm going to do is I'm just going to keep it as a square root of 29. And I know it's approximately going to equal 5.385. I want to go at least 3 decimal places, usually 4. So 385, I'll go out 4 decimal places. So it's approximately equal to 5 point something. But in my little graphic organizer that I've created here, I'm going to leave it as square root of 29. because I'll let the calculator do all the work. And the last side length that I need to solve for is AD. Let's take a look at AD. Again, notice AD is slanted. So we're going to go ahead and do the Pythagorean theorem to figure out the length of AD. Okay. Create the right triangle. And here we go. Two boxes, so 2 for the vertical length. 1, 2, 3, 4, 4, 5, 6 boxes for the horizontal. So I'm going to use 2 and 6 to figure out the length of AD, which is like my C value. Okay, go back to my space where I have some room to work. And okay, here we go. AD. We had 2 squared plus 6 squared. And you may have seen this before. Instead of writing C, which I absolutely can, I can absolutely write C squared, I'm going to put AD squared, which is much more mathy, much more sophisticated. It's really that length squared, which I can call C, but AD is much more specific and accurate. Okay, 2 squared is 4 plus 36 equals AD squared. 4 plus 36 is 40. That gives me AD squared. And I just want AD, just want the length of the line segment. I don't want it squared. So to get rid of the square, I'm going to square root both sides. Cancels out the square, which leaves me with the square root of 40 as the length of AD, which, again, I'm going to write down approximately what it's equal to. So in the calculator, I'm going to put 40, square root, and I get approximately 6.3246. But in my little graphic organizer, I'm going to keep it as square root of 40. So remember, perimeter means add up all of these lengths. Square root of 29 is approximately 5.3, so on and so forth. Square root of 40 is the 6.32, so 6.3, so on and so forth. So really I'm doing 3 plus 4 plus 5 plus 6. So approximate how much that is. That's around 18, maybe 19, something like that. Let's go to our calculator and let's do it the official way. 3 plus 4 plus 29 square root plus 40 square root equals 18.7. Yep, that makes a lot of sense to me. So altogether, this is about 18.7 units for the perimeter. And it did say round to the nearest tenth. This is my final answer. So as a recap, when they ask you for perimeter, all that means is you're finding the length of all the sides of your shape and adding them together. And you could still use the Pythagorean theorem to find the length of any of the sides that are slanted. If they're not slanted, you don't have to do the Pythagorean theorem. You can just count the boxes. Okay, so let's move on to the next video.